Hello guys, so today actually we continue teaching machine design course, chapter brake system, today part 2. So the part 2 actually I will explain, I will summarize and I will explain clearly first of all I will start with the samples and units and equation and the converting system. So converting the unit, okay? So first of all, just focus. Please guys, actually review the part 1 of the brake system. I was explained, I was clarified all the 4 types that you must focus on it. Just focus on these 4 types. The last session, the part 1. So the part 2 we continue teaching the samples and units. First of all, the first sample is the TB. What the TB is? The torque. The unit of the torque is Newton. The FT is the tangential force. It's the unit Newton. Rn is the normal force, Newton. M is the coefficient of fraction, unitless. 2 theta is the angle contact in degree. N small. Actually, just focus here. You must actually distinguish between the small n and the bigger n. The small n is the number of the turns, the down turns. So just focus on the turns. The turns unit, there's no unit, you just write 5 turns, 6 turns. The n capital is the rotation. It's the rotation. It will be specified in the question. Is the rotation is and the unit is RPM. So the small n and the bigger n. The small n is called the number of turns. The capital letter of the n is the rotation in RPM. The last one is the time in seconds. So these the samples of this chapter. Just focus. The equation in this chapter, actually the TB, the torque, it's equal FT multiplied with R, or also TB equal the coefficient of fraction, the normal force multiplied with the radius. The coefficient of fraction, actually here, wait, I will write not. Okay, let's do it. Okay, here the coefficient of fraction equal 4m sine theta, 2 theta plus sine 2 theta. Great. The FT, the tangential force, equal the coefficient of fraction multiplied with Rn. The work done equal the kinetic energy. The kinetic energy, the work done equal the TB multiplied with 2 by n for the work done. For the kinetic energy, half mv squared. Great. The time equal n capital over n small. The number of turns over the rotation. So just please note, because actually this step you will follow all the questions. This step you will be followed in all the questions. What are the steps? You guys focus here. If focus, okay. If m that's given, no, not m. Sorry. If focus. If the 2 theta angle of contact bigger than 60, if 2 theta bigger than 60, so you must use because the coefficient of fraction to be given and the question specified, for example, was 0.35, so to be given, okay. If it be given, so actually to also will be given the angle of contact. If the angle of contact is bigger than 60, so you cannot use this this coefficient fraction in all the formula to be wrong. 0. No, you cannot use it. If was bigger than 60, you will go and use that equation. You will be actually you will have m dash, not m without dash. You will have m dash. If the 2 theta bigger than 60, you must get the m dash. Great. be focused here. Note, because actually most the student forgot actually to do these steps. So if 2 theta is less than 60, if 60 bigger than 2 theta, then in this case m will be equal m dash. Okay, just in this case you can use the m that is specified and given in the question. The m equal m dash if it was the angle of contact less than 60 bigger than 2 theta. So when we go to the converting part, it's a very easy converting part. The n times millimeter, you converted the millimeter to meter, then you can to Newton, the meter to second, the degree to radian. Okay, where I can convert the degree to radian, and where I just put directly the degree. So actually, please you guys note here, in this question you will use the degree and the radian. Degree and the radian, here you will use it. Just focus, guys. So here on the sign I will put degree, and sign here I will put degree, sign I will put degree. Great. Sign I will put degree. Okay, and the sign actually I will put degree. In the 2 theta, this without cosine and sine, actually I cannot put degree. Here I'm supposed to put rad, and I know how to convert it. That's all. So now we continue for the first question. Hello guys, so we continue on the first question. The first question is on the first type. You can move on and go for the first session that I clarified and explained all 4 types. So now the question about the first type of the brake system. Single brake system, very easy and simple. So that's the shape of the brake system question. That's the first question. So the first thing you must do to solve this question, you must follow these steps. So the first step, you specify the fixed point, set the forces, checking for r theta, for the n, for the coefficient of fraction, take the moment on the fixed point. So the fixed point, so guys, the fixed point to be specified in the question, to be, for example, part A, it is the fixed point. Great. So set the forces here to be given a new exam. So it will be given the direction of the dart, counterclockwise or counterclockwise. Great. So here it's given it is clockwise. So how can I set the 2 forces that I explained in the session 1? The 2 forces, the 2 forces is, the first one is the FT, the tangential force. The second force is the RN, is the normal force, it's vertical on the tangential. So first of all, where I supposed to apply the FT, the tangential force. So I go with the rotation of the arm, so the rotation is become like this and end here. Great. That's one called the FT. That's what called what? That's what called FT. That's what called FT. That's what, okay, sorry. That's what called FT. That's what called the FT. Okay, okay. We move on now for the we move on. So in the second part, so the second part is about the normal force. The normal force, it's always vertical to the tangential force. So from the center, I put like this vertical line. It is vertical, the FT force, the R and normal force. So I have 2 forces now, the tangential force and the normal force. Okay, so I do first steps, I done the second, I done the first and the second. Now the third step, checking the r theta for the coefficient of fraction. So when we see the given, the given that the r theta equal 90 degrees. So as I explained before, that if the r theta is bigger than 60, so I can't use the coefficient of fracking that's given. I can't use it in the formula and the solving the problem. I'm supposed to convert it to the m dash. So I take the m dash. It's 4m sine theta 2 theta plus sine 2 theta. Great. So the m dash now here, the m dash 4 multiplied by m, that's given, multiplied by sine 45. For the theta 45. Why? Because actually I have the 2 theta equal 19. I want theta divided by 2. Divided by 2, I will get theta 45 degrees. Great. So, okay. The 2 theta, guys, just focus. Here 2 theta without any sine and cosine. So I'm supposed to convert it to the radian. To the radian. Hello? I'm supposed to convert Shabab to the radian. ليش؟ لأن why? It is 2 theta. There is no sine and cosine. There is no angle specified here. So the 2 theta convert. Focus. 2 theta convert to radian and multiply with by over 18. So 19 multiplied by over 80, I will get by over 2. Great. So by over 2 plus sine 2 theta, because it's sine angle, I put the degree part. Great. I will get the m dash 0.385. So now we shift, just focus this. Okay. So now we shift in this part. This part is clear. Okay. Sorry. It's clear. Okay. So now it is the easy one, the easiest part. It is like basic one, mechanical material, the basic thing. Take the moment at point A. Come on, just take the moment, simple moment. Anybody can take the moment. The rule of the hand, right? And take the moment in point A. The three forces, the P forces, the Ft, and the Rn, the tangential force. Okay, great. So first of all, we take what? First of all, we take the moment at point A. Okay, we take the moment at point A. The Ft with the vertical distance. Just simple mathematics. So it is mathematics applied. Very easy to solve the moments. Okay. After you take the moment, you take for the P, for the Ft and the Rn and point A. Great. And all the distance is specified in the question. Great. So when I take the moment, I will end up with here 700 minus 700 times 40, 450 minus 50 times 50 plus Rn times 200 equals 0. Great. So minus okay. So okay. So minus 700, as I repeat again, I come with that. So the Rn, I have the Rn is equal Ft over m dash. The equations that I explained before. So the Rn equal Ft over m dash. Great. So I take the Rn on the other side. Okay, I will get 200 Ft over 0.385. Great. So I have everything. I come back to the I substitute to this equation. Okay, great. So I'll have one unknown, one equation, and get Ft. That's all. Easy peasy. ايزي شباب. شنو بس يجيب مومنت وش حط قانون اف تي على ام داش. زين الان شو يسوي؟ اف تي على ام داش. تمام. خلي الان بروحه طلعت هذا. تمام بس تمام. صار اف تي على 0.3 مع قوانين تسوي شرط عليه. Okay, great. So continue. Substitute in the moment about point A, and you get 50. Great, Newton. And he won the torque. The torque equation 50 times the radius. the radius. He gave you actually the diameter, the radius, divide by 2, you got the radius, okay, 21,125, okay, and you got the TB, Newton times millimeter. You're supposed to convert it to Newton times meter, multiply with 10 minus 3, and that's the first type is done. See you for the next